All right, so an angle consists of two different rays that have the same initial point. This is an example of an angle. There are three different ways to name this angle. So this point where both of the rays meet, that is called the vertex. And then the two ends on the side are the sides. The rays are the sides of the angle. The initial point is the vertex of the angle. So there's three ways to name this angle. You can just call it angle A. You can call it angle CAB, or you can call it angle BAC. Two angles are adjacent angles if they share a common vertex and side, but have no common interior points. So this first example, angle 1 and 2, these are adjacent angles. They're not touching, they are non-adjacent. Five and 6 are adjacent. 7 and 8 are non-adjacent. Adjacent angles are kind of side by side. 1 is next to 2, 5 is next to 6. Those are adjacent. Right? Classifying angles. Angles can be classified as acute, right, obtuse, and straight. So the acute angle here, I'm going to highlight it in yellow. That means it's between 0 and 90 degrees. It cannot be over that amount. So 89 degrees is an acute angle. It's got to be less than 90. It cannot equal 90. If it equals 90, this is the green one, it is a right angle. A right angle is exactly 90 degrees. And the way you know it's a right angle is that little box in the corner. You see the little box they made above A? That means that is a right angle. That means it is exactly 90 degrees. An obtuse angle is more than 90, but less than 180. Obtuse angles would be between 90 and 180. So it's more than 90, but less than 180. A straight angle is a straight line, and it is exactly 180 degrees. A straight angle is also known as a straight line, but it's exactly 180 degrees. Okay, so those are angles. And just like segments, if it says measure of angle BAC equals measure of angle BEF, that just means those two angles are equal to each other. Angles are congruent if you see that other symbol with the squiggly line. Angle BAC is congruent to angle DEF. That's what this is saying. Okay, using angle postulates. This is postulate 4, angle addition postulate. If P is in the interior of RST, so RST would be the big angle, then the measure of angle RSP plus the measure of angle PST equals the whole thing, which is RST. So those two angles added together is RST. For example, in the figure above, the measure of CDE is 62 degrees. and the measure of angle EDF is 18 degrees. Find the measure of the whole thing, CDF. So that was CDE, which is 62 degrees, and this was EDF, which was 18 degrees. If you add those two together, it's the whole thing, CDF. 62 plus 18 equals 80 degrees. All right. So the measure of angle CDF is 80 degrees. Example 2. It says if the measure of KJM, that is this whole angle here, those two adjacent angles added together, is 145, and we know that the measure of angle KJL is 6x. So KJL is 6x degrees, and the measure of angle LJM is 3x plus 10 degrees. Find x. So you know those two added together equals 145. So 6x plus 3x plus 10 equals 145. 6x plus 3x is 9x plus 10 equals 145. Subtract 10 on both sides. You get 9x equals 135. Divide by 9 on both sides, and you get x equals 15. And it just said to find x, and we've done that. We found x. We're done. All right, moving on. An angle bisector is a ray that divides an angle into two angles that are congruent. In example 3 in the diagram at the right, YW bisects XYZ, and the measure of angle XYW is 18. Find the measure of XYZ. So we know the measure of angle XYW is 18 degrees. Well, if YW bisects that angle, that means the other side is exactly the same. So that's 18. This is also 18. Find XYZ. XYZ is the whole thing. So all you have to do is add 18 plus 18, and you get 36. So the measure of angle XYZ is 36 degrees. All right, moving on. Example 4 in the diagram, the ray MO bisects the angle LMN. The measure of the two congruent angles are 3x minus 20 and x plus 10. Solve for x. So you know if that ray bisects that angle, it cuts it in half, right? So if it cuts it in half, both of those are equal. So you set them equal to each other. Each side is equal, so 3x minus 20 equals x plus 10. Then you just solve for x. Subtract x on both sides. You have 3x minus x is 2x. Then you add 20 to both sides. You get 2x equals 30. Divide by 2 on both sides, and you have x equals 5. That should be 15. That should be 15. Let me, right, that should be 15. So change that on your papers right now. This should be 15. 30 divided by 2 is 15. Two angles are complementary angles if the sum of their measures is 90 degrees. Two angles are supplementary angles if the sum of their measures is 180. Sum means if you add them together. Supplementary and complementary angles can be adjacent or non-adjacent. The first two are complementary adjacent. The next two are complementary non-adjacent. The next two, those are complementary and adjacent, or supplementary and adjacent. The last one is supplementary, but they are not adjacent. Okay, this one is complementary because 28 plus 62 is 90. This one is supplementary because 155 plus 25 is 180. That one is complementary because 30 plus 60 is 90. And then the last one is supplementary because 60 plus 120 is 180. All right. Example 5, given that the measure of angle S is a complement of angle T and the measure of S is 32, find the measure of angle T. Complement means added together they equal 90. So 32 plus something equals 90. Therefore, 90 minus 32 would give you what you're looking for. 90 minus 32 is 58. 58 plus 32 is 90.